Okay, welcome to another Ginger Mathematician video. Today I'm doing an updated iGCSE all of probability for 2025. That means I will generally be using non-calculator methods unless it's clear it's a paper 4 question, in which case I will refer to my trusty calculator. Right, let's get started here. So, question 8a. So a bag here contains 24 coloured beads. Now some are red, some are blue, and 10, that's important, are yellow. One bead is picked at random from the bag. What is the probability that the bead is yellow? So we have 10 yellows. Out of how many in total? Well, we have 24. So we can write in 10 over 24. Now, generally, you should look to simplify your fractions. This is definitely a non-calculator idea here. And notice we can divide top and bottom by 2. So if we divide top and bottom by 2, we can simplify our fraction. 10 divided by 2 is equal to 5, and 24 divided by 2 is 12. Generally, and we'll look at mark schemes at the end, they're generally quite reasonable and use this OE or equivalent to give you the mark. Now we've got the probability that the bead is not yellow. Remember, all probabilities have to add up to yellow. So the probability of yellow plus the probability of not yellow, which we use this dash for, again, getting lots of useful tips in this video, is equal to 1. So if we've got 5 over 12, and we need to add something to it to make 1. Now remember, 1 is the same as just 12 over 12. So what do we add to 5 to get to 12? Well, that's going to be 7 over 12. So we can write in 7 over 12. Even though of those 7 over 12, or what's it going to be, 14 out of 24, some will be red, some will be blue. That doesn't matter. All we care about here is it's not yellow. And on to the next part of the question. So another bag here contains 5 green, 6 white. I usually underline these. 5 green, 6 white, and 4 black marbles. Mira picks 2 marbles at random from the bag without replacement. This is the most important phrase. I'm going to put 3 lines under this to make my point. Without replacement, that means it does not go back. So I'm going to literally write that next to questions. That's reminding me to remember that as I do this question. So we want to find the probability that the first marble is black and, again the key word and here, I'm going to put a little box around it, and the second marble is white. So we want the probability of first black and then second white. So the probability the first marble is black, while we have 4 black marbles out of how many in total? Let's double check. 5 plus 6 plus 4. So we're going to have then 15 in total. So 4 out of 15. Because we have this word and, we're going to be doing some multiplying. Again, nice little trick to know. And we want the second marble to be white. Now, nothing goes back, so now we have 14 marbles left. How many are white? Well, we've still got 6 white marbles. Nothing has disappeared. So we get 4 over 15 times 6 over 14. Now, we can do some simplifying here. I'm just going to go to my calculator. Ta-da, there's our calculator here. Again, standard class whiz, so again, typical functions that your Casio or similar calculator has. So if I type this in, the great thing about using your calculator, particularly in the paper 4 questions, is that it'll do the simplifying for you. So if we type this in, 6 over 14, boom, it gives us 4 over 35 directly. Okay, so, and we don't have to think about too much of the simplifying. Now for the next question, we have both marbles have different colours. Now the way I generally approach these, as soon as I see the word different, that's usually more combinations than you really want here. So the way I work out this is going to do it negatively. So I'm going to do 1 minus the probability that they have the same colour, because the marbles, in this case, that we have here, can either have the same colour or different colours. So I'm exploiting this fact, and the reason I do it this way round is it makes it easier to do the calculations. Because what I can do now is do 1 minus the probability of black, black, plus the probability of white, white, and the probability of green, green. Don't forget green, green. And this is much easier to work out than actually working out blue, green, blue, white, white, green, and so on. So to work out the probability of black, black, so we have 4 black to start with, so we have 4 over 15. We want and black again. So notice there's a kind of hidden and here. So we then multiply by, well, we've got 14 marbles and we only have 3 black. Again, you can put this in brackets. Your calculator is usually good enough to work this out. If we do the same with white, then we have 6 white to start with, so 6 out of 15. We lose 1 of each, so we only have 14 now, and then 5 of the white. And then we have green, so let's work our way through this. So we have 5 over 15, 10 times 4 over 14. The pattern is also easier to work out as well, because otherwise if you do, for example, first marble black, second marble white, then you have to remember that you've lost 1, so you've got 14 in total, but the amount of white stays the same, so it keeps things a bit trickier. Once I've written that working down, that's all I need to do. I don't need to write anything else for the examiner. So now I'm just going to use my calculator very carefully and make sure that we type this in correctly. So 1 minus, and now we're going to start our fractions in here. So again, as you go through this, just be really careful, and in the exam, it's a nice quiet environment so you can concentrate, taking your working and making sure you're writing exactly the same thing, because this is where mistakes are made. Again, most people skip this part of the video, but you shouldn't do that. You should make sure you're happy not making a mistake as you go through. Again, it's quite the skill actually talking about this as I'm typing it in, and we'll see if I make a mistake. So what we got, last one, so 5 over 15 times 4. And don't forget we've got 2 brackets at the end here. Bracket for the whole calculation and bracket for that calculation. So we press the magic equal button, we then get 74 over 105. Again, the simplifying also gets done for us automatically, so we don't need to try and work out here if we need to actually simplify this fraction or not. So nice little trick here. So if you ever get a different question, and this also applies at A level, you do like permutations, combinations, you have a positive way, so add up all the combinations that fit the condition, or 1 minus the opposite of it. And I've taken this 1 minus the opposite because it takes far less time to do. So you can have a look through the mark scheme. Again, we've taken this approach here. As long as you write this down, then you get 3 marks anyway. If we make a mistake here with the particular fraction by typing it in a calculator, we still get a whopping 3 out of 4 marks here. Okay, on to the next question. And if you're liking the video, then please do smash that like button. It means it can spread out to a ton of people. And it's such a great feeling when you see hundreds of thousands of views on these videos helping students for the last 4 or 5 years. And it really, really makes it really valuable. Okay, so question 5. A box contains 3 blue pens and 5 red. I always underline this. Picks a pen from the box at random probability she picks a red. This is very standard. They usually do like a 1 marker to get you warmed up. So we have 5 red pens and we have 8 in total. Notice 3 plus 5 is equal to 8. So making sure we're careful there. Mia puts the pen back into the box. She then picks a pen at random and replaces it. Then picks a second pen at random. Okay. So it looks like this is just a normal one because we've got this keyword replaces. So when we fill in the fractions here, we have 3 out of 8 and 5 out of 8. And because there hasn't been a change, you pick a pen, you look at it and go, oh, it's red or blue. You put it back in. So again, the second pen, that's still going to say 3 out of 8, 5 out of 8. This is where reading the question is really careful, really important. And this is only a 2-mark question, so it shouldn't be anything too difficult here. And then we usually have to use this in some way. So the probability that Mia picks 2 pens that have the same color. So we want the probability of same. So we want the probability of blue, blue, plus the probability of red, red. If you're wondering why we add here, this is always a question I get from students, is the probability of blue, blue, or the probability of red, red. As soon as you start using this word or in probability, we're going to be doing some addition. So probability of blue, blue. So that's going to be 3 out of 8 times 3 out of 8 plus the probability of red, red. So that's 5 out of 8 times 5 out of 8. I don't have to use a calculator here. Remember, timesing fractions, we just times top times bottom. So we get 9 over 64. And then we get 25 over 64. We add fractions with the same denominators. We just add the bottoms. So we get 34 out of 64. And that does simplify here. So that's going to simplify by dividing by 2 to get 17 over 32. So notice I'm not rushing to my calculator if I don't have to. If I'm confident with my multiplying fractions and adding fractions, again, I do encourage you then to try and work as quickly as you can through these problems and therefore pick up the 3 marks pretty quickly. Now, Mia now picks 3 of the 8 pens in the box at random without replacement. Ah, no! It makes things so much harder. Find the probability that she picks 2 blue pens and 1 red pen. So, to have this condition, we then have either, and I'm just making sure we read the question carefully, she picks 2 blue pens and 1 red pen. It doesn't say about order, so blue, blue, red is possible. Then we also have the possibility of red, blue, blue. And we also got the possibility of blue, red, blue. So notice it's not very specific in the question here. She picks 2 blue pens and 1 red pen. It hasn't said about the order. So that's important. Now, without replacements, we have to be careful here. So the probability of blue, blue, red. So we start with blue is 3. So 3 out of 8. Then we do another blue, so that's going to be 2 out of 7. And then we do red. Now, red hasn't changed in the entire problem, so there's still going to be 5 red here out of 6 remaining pens. And then we do the next one. So we have red here, so that's going to be 5 out of 8. Then we've got the blue pen, so that's 3 out of 7. Then we have the blue pen, so that's going to be 2 out of 6. Hopefully there's something you notice here as we do this question. And the last one, so we have blue, so that's going to be 3 out of 8. Then we have the red, so that's 5 out of 7. And then we have the next blue, so that's 2 out of 6. Notice these are all the same calculations. The 5s, 3s and 2s are all different ways round, but we still essentially have the same calculations. So essentially, we're just going to have 3 lots of the same thing. That's going to save us a bit of time. So if I go to my calculator, we can actually then just do 3 out of 8. So let's type this in, take the first one, times 2 out of 7, because it's the same calculation, just the numbers are in different order, times 5 out of 6. So it gives us 5 out of 56, but we can just times this by 3, and this will give us our final answer of 15 out of 56. Again, it simplifies it straight away for us, so we don't have to think about, is there any way to simplify? So we could have typed this entire calculation in. This is true, but we are looking for shortcuts to make sure you can save that time here and then have more time on the differentiation or the vectors, or whichever topic that you struggle with. Notice we have 3 lots of this, 1, 2, 3, and therefore we can make this calculation a little bit quicker, saving you maybe a minute in the process. Okay, so here's the mark scheme for question 5, so you can see all the ways that you pick it up. Again, you get 2 method marks just for writing down what I did. Again, make a mistake, we still pick up 2 marks out of 3. Okay, on to question 9 here. So a bag contains 5 white and 3 black balls. Nice little picture to help us here. Marwan picks a ball from the bag at random and replaces it. That's important. Find the probability that the ball is white. So again, these standard 1 markers, we have 5 white balls out of 8 in total. 5 plus 3 is equal to 8. Something slightly different here, so that's nice. So Naomi picks a ball from the bag at random and then replaces it. Aha, she repeats this, again I'm looking for these keywords, 120 times. Find the number of times the ball is expected, important word, to be white. Now to work out any expectation, all we do is take the probability, so probability of white in this case, and times it by the number of times. So in this case 120. So that gives us then 5 over 8 times 120. Now what we should always look for here is some way to simplify. So if it's a non-calculator question, this looks more of a non-calculator question, we should try and find ways to simplify. So notice you've got an 8 at the bottom and 120. So what we can actually consider here, again a little bit of bus stop division. How many 8s go into 12? Well, 1, remainder 4, and 8 into 40 go 5. So we can actually simplify this by doing 8 into 8 go 1, 8 into 120 go 15. So to work out this answer, we just need to do 5 times 15, which again, if you're really unsure with your mental maths, again, the answer is 75 here. Then you can always do this by just doing 15 times 5, 5, 2. 1 times 5 is 5, time plus 2 is 7. Again, lots of ways to do written multiplication, but most people like this old school approach. I don't actually, but that's a topic for another video. Right, on to part B. So Oscar here picks a ball from the bag at random. He replaces it and then picks a second ball from the bag at random. So keyword replaces, so it doesn't change. Find the probability that the balls are the same color. Again, we've seen this idea before. So probability of white, white, plus the probability of black, black. So probability of white, white, again, is replaced, so the probability stays the same. So we get 5 over 8 times 5 over 8. And then black, black is 3 over 8 times 3 over 8. Again, not rushing to my calculator. I can times fractions. So times these together, 5 times 5 is 25. 8 times 8 is 64. 3 times 3 is 9. 9 over 64. At the top, so we get 34 over 64. I think it's the same calculation we did before, actually. 17 over 32. Again, let me know in the comments below if it actually is exactly the same. I think it is, isn't it? 17 over 32. Naughty examiners doing basically the same question. And now there's a little twist to this. So find the probability that the balls are not the same color. So we can be a bit lazy here because the probability of same plus probability of not same is equal to 1. Again, please don't sit there and do white, black, black, white, etc. That takes a little bit too much time. So 17 over 32 plus something gives me 32 over 32. That's going to be 15 over 32. It's a 1 mark question, so it shouldn't take us too long to work out. Okay, and this question is pretty much the same as before. So picks 3 of the 8 balls, bag at random without replacement. Find the probability she picks 2 white balls and 1 black ball. Again, same idea here. So the probability of white, white, black, plus the probability of white, black, white, and then plus the probability of black, white, white. I would like you to pause the video at this point and have a go at this question yourself. This is a good way of testing. Have you taken the previous knowledge I've shown you and apply it to this particular question? So pause the video and see if you can work this out. Hopefully you did that at home and hopefully you got the answer of 15 over 28. So we've seen this style of question already. Again, you can go through the mark scheme and check your understanding of the content. Okay, on to the Venn diagram question. So I thought I'd sneak this in for a 1 mark question, just so you're up to date with probability and Venn diagrams as well. So 75 people are asked if they have a car or they've got a job, and the Venn diagram shows the result underneath. A person is chosen at random from those that have a car. So I'm going to put a circle around those people that have a car. So there are 51 plus 9, so that's 60 that have a car. Of those 60, so from the 60 people, find the probability that this person also has a job. Well, that's the part in the middle, so it's going to be 51 over 60. However, be careful because this does simplify. We can actually divide by 3 top and bottom. A way to check this is add the digits and see if it adds up to a multiple of 3. So 5 plus 1 is 6, 3 goes into 6. 6 plus 0 is 6, 3 goes into 6. Now 51 divided by 3, if you're not happy with that, again, a quick bit of bus stop. 3's into 5 go 1, remainder 2. 3's into 21 go 7. So we get 17 at the top. And 60 divided by 3 is 20 for our 1 mark. They are quite nice. They give you this or equivalent. So if I left it as 51 over 60, I'll probably still get the mark. But please don't risk it in the exam. On to question 10 here. So Jacinda here is playing a game with her friend. She can win, lose, or draw the game. Probability she wins is 0.28. Jacinda is twice as likely to draw the game as to lose the game. Okay, so if the probability she loses is, say, x, let's just give it a letter, then twice as likely to draw will be 2x. And work out the probability she loses. So Again, it can either win, lose, or draw. So you can either win, so 0.28. You can draw, which is 2 lots of x, or you could lose, so that's x. And this all has to add up to 1. Notice, from that reasonable explanation here, I've actually generated an equation I can solve. So 2x plus 3x, 2x plus x is equal to 3x. And we can also minus 0.28 from both sides. This cancels, and then we have 1 minus 0.28, so that's going to be 0. Now be careful with your decimals here, this is going to be 7.2. Again, you can always double check by adding them together, and then what's the opposite of timesing by 3? We divide by 3 on both sides. This cancels, giving us x, so the probability of losing, and then 0.72 divided by 3. Again, we can just do some bus stop. 3's into 7 go 2, remainder 1, 3's into 12 go 4. So we get our final answer here of 0.24. That gives us the 2 marks here. Now, Jacinda plays the game 150 times. That's a long time to play some games. Find the expected number of times she wins. That's important. So we don't need part A to do part B. That's nice. So we have 0.28. Remember that expected wins is equal to probability, so 0.28, and then times 150, the amount of times that she plays. Now, that's fairly tricky to do. Again, we could actually do some long multiplication. What I prefer to do here instead is actually write this as a fraction. So we have 28 over 100 times 150, and then we can do some cancelling. So how many 50s go into 100? Well, 2. How many 50s go into 150? Well, 3. And so that gives us 28 over 2 times 3. 28 over 2. So that's just equal to 14. And 14 times 3. Again, we could work that out. Fairly easy to just be 42. Again, not happy with that. Again, a lot of you are quite anxious about this non-calculator exam. Again, you've always got written methods. 4 times 3 is 12, carry the 1. 1 times 3 is 3, plus 1 is 4. So if you're really unsure, even something like 14 times 3, I have students that, any kind of multiplication division, they get panicky about it. You can always use written methods. Get the 42, that gives you the mark. So there we are, that picks up our 3 marks here. Now we're into quite a long question here. So question 7, so this is going to be a calculator question if we need it. So 2 fair dice. Numbers on dice A are 0, 0, 1, 1, 1, 3. So numbers on dice B are 1, 1, 2, 2, 2, 3. Dice is rolled, the score is the number on the top face. Okay. Dice A is rolled once. Probability, it is not 3. So notice the probability of 3 is 1 out of 6. So not 3. It's all the others. So 1, 2, 3, 4, 5. So that's going to be 5 out of 6. Dice A is rolled twice. Find the probability that the score is 0 both times. So 2 lots of 0. So to get 1 lot of 0, it'll be 2 out of 6. And then we do it again. Again, dice doesn't change. So we haven't used up a side, so to speak. So it's also going to be 2 out of 6. Now remember, 2 out of 6 is just the same as 1 out of 3. So doing 1 out of 3 times 1 out of 3, and that's equal to 1 over 9. So this kind of question, they do like to warm you up here. I think the answer, say 4 out of 36. Again, try and simplify when you can. So we've got the nice easy 3 marks, building your confidence for the harder part later. So part C, dice A is rolled 60 times. Calculate an estimate of the number of times the score is 0. So estimate of 0, so that's going to be the probability of 0, so that's 1 out of 3 times 60. Okay, that's quite a nice one to do. That's just going to be 60 divided by 3, and that's equal to 20 times. So be familiar with expected. That does come up now more and more in these questions. Okay, part D, dice A and B are rolled, each rolled once. The product, important word. The product of the scores is recorded. So when it says product, it means multiply together. Complete the possibility diagram. Also known, I use the phrase sample space, but some teachers will use this phrase possibility diagram as well. So if we look at our diagram, anything times 0 is 0. So you can see they've got a lot of zeros. 1 times 1 is 1. So looking at the pattern here without even reading the question is quite helpful. So 1 times 3 is 3. So these are all going to be 1s. 1 times 1 is 1. 1 times 3 is 3. In fact, these two rows should be the same. 1 times 2 is 2. 2, 2. 2 times 3 is 6. This is going to be the same rows here. So 2, 2, 2, 6. And 3, 1 times 3 is 3, 3, 3, and 9 in the corner. Okay, 2-mark question. They don't often put these possibility space diagrams, but they have done. It's not as if it's never appeared. Okay, and now find the probability that the product of the scores is a 2. So how many 2s do we have? Well, it's this part here. So we have 9 2s out of 36 in total. So 9 over 36, which of course we can simplify to 1 over 4. Again, answer gives this, but I prefer simplifying. Greater than 3, so not including 3. So it's just going to be these 4 here. So that's going to be then 4 over 36, and that's equal to 1 over 9. So we're just using that table and just checking your understanding of that table. So IFA keeps rolling dice B until 1 is scored. Okay, let's go back to dice B. So 1, 1, 2, 2, 2, 3. Okay. Find the probability this happens on the 5th roll. So we want the probability of not 1, not 1, not 1, not 1, and then finally getting a 1 on the 5th roll. Okay, so not 1, if we go back to the question, that's going to be these 4 numbers here. So 4 out of 6. So we're going to do 4 out of 6 times 4 out of 6 times 4 out of 6 times 4 out of 6, and finally we get what we want, which is the 1. So 2 out of 6. Now notice we're timesing by itself 4 times, so we can actually write this in a much more neat way. So 4 out of 6 to the power of 4, because we have 4 times of it, and then 2 out of 6. So this is something I can certainly not do in my head, so I'm going to go to my calculator. Gives me an opportunity as well to show you where the power button is. So 4 out of 6. Close bracket. Now we press this button here, so x with a little square. That means to the power of 4. Then we times it by 2 out of 6, or 1 out of 3. And then we get some big fraction, 16 out of 243, which again your calculator simplifies for you. You'll notice in the answers here, let me just give you the answers, it gives you this horrible big fraction instead, but it is the same as what I've just shown you. Okay, on to the next question, something a bit more tough compared to what we've done so far. So Angelo has a bag containing 3 white counters and x black counters. So that means we have x plus 3 counters in total. I'm doing these things as I go along. He takes 2 counters at random from the bag, without replacement, so reduced by 1, okay. Probability Angela takes 2 black counters is the following. So, so first of all we have x out of x plus 3. And then we have 1 less than the x before. And then how many do we have left? We had x plus 3 before. We've lost a counter in general. So this is going to then be x plus 2. Okay. And now from this, and we've got told the probability that Angelo takes 2 black counters is 7 over 15. Show that this quadratic appears from nowhere. Okay. So we take the answer we have before. So we have x over x plus 3. Times x minus 1 over x plus 2, because that's the probability it takes 2 black counters, and this apparently is equal to 7 over 15. Okay, so first of all we can just put the 2 fractions together, so we get x brackets x minus 1. The key thing with this kind of question is simply not to panic. Equals 7 over 15. Now when I have fraction equals fraction, we can actually just cross multiply here. Nice technique to know. So that means we get 7x lots of x minus 1 equals 15 lots of x plus 3, x plus 2. Okay, so now it's just a case of expanding and making sure that we're accurate. So we can multiply out a single bracket, so that gives us 7x squared minus 7x. First of all, I'm going to multiply out using FOIL. So first, outside, inside, last. So x times x is x squared. X times 2x is plus 2x. 3 times x is 3x. 3 times 2, be careful here, is equal to 6. Amazing how many people make mistakes. Right, let's tidy up the right-hand side. So we're going to times everything by 15 here. So notice these two things together gives you 5x here. So 15 times x squared is 15x squared. 15 times 5x is 75x. And 15 times 6 is 90. Again, any of those kind of calculations like 15 times 5, you can always use written methods here. Okay, so you've always got that to hand. Okay, let's bring everything to one side. So I'm going to minus 7x squared and add 7x to both sides. So these all cancel, giving me 0. 15x squared minus 7x squared is 8x squared. Okay, we're getting similar to what we have there. What do we have next? 75, add this on, that's 82x. I feel like I've gone wrong somewhere, and we'll talk about that in a moment. Plus 90. Okay, so I know I've gone wrong here already, because if I'm looking at this, I'm not getting the same things that I've looked for. So this is a good exam technique. This is why I don't take this out of the video. What have I done wrong? I'm sure you've already been shouting at the screen for the last no idea how many minutes. And there is a very clear thing that I have done wrong. So don't panic. This happens. Because you try and do this fairly quickly. Well, cross-multiplied, this should be the 15, and this should be the 7. So I'm going to change this to 15, change this to 7. The multiply out the FOIL is perfectly fine. So I'm just making alterations here. I'm not panicking here as I do this. So we have 15x squared, we have 15x, and we have a 7 here. Okay, so then we just keep going as we did before. So minus 15x equals 7x squared. Okay, this makes a bit more sense, I think. 7 times 5x is 35x. 7 times 6 is 42. Okay, these numbers make more sense. So again, we do the same process as we before. 15x squared plus 15x. So these disappear. So we get 0 equals, okay, so 7x squared minus 15x squared, that's minus 8x squared. Plus 15x, that's plus 50x, and then plus 42. Okay, I'm going to swap this over. So minus 8x squared plus 50x plus 42 is 0. And if I divide through by minus 2, this is the key step. Minus 8 divided by minus 2 is positive 4x. 50 divided by minus 2 is minus 25x. Look at that. 42 divided by minus 2 is minus 21. And we get exactly the quadratic that we were looking for. So these show that questions are great because you can make mistakes, but you can go back and then check and go, ah, that's where the mistake was. Okay, I can fix it, keep calm, and get those 4 marks. Now, unfortunately here we have to solve by factorization, so we can't use the formula. Something in 2025, they are putting this by factorization phrase in, stopping you from just going to your calculator or going to the quadratic formula straight away. Now, how do we factorize this? Now, I'm going to show you my quick method. I know lots of teachers do splitting the term, but I think this is simply quicker and a bit of a hack. So we're going to set up our brackets. To get 4x squared, there are 2 ways of doing this. You can either do 4x and x or 2x and 2x. But one thing I notice here is these 2 numbers are fairly similar. They're quite close to each other. So I'm going to suggest that 2x and 2x is probably going to be more likely. It doesn't have to be, but it's usually more likely. And 21 as a number, to get 21, we have 1 and 21 and 3 and 7. Again, with minuses and pluses in different places. And because the numbers are close together, 3 and 7 are probably going to be my answers. So with that together, let's see if we can work this out. So we've got minus 7 and 3. Looks like it's not going to give me enough to get to minus 25 here. So I might have to change my approach and look at 4x and x. Again, fine to try this approach. Let's try 4x and x here, because I need to get this minus 25x. So I've got a minus 7 here. 4x times minus 7 is minus 28x. Aha, if I put a plus 3 here, plus 3x, and I'm just checking the middle terms of FOIL. So we get minus 28x plus 3x is minus 25x. Good, I do get the middle term that I'm looking for, which is important. So that means then, if we work out the two answers here, either 4x plus 3 is 0, so 4x equals minus 3, x is equal to minus 3/4, or x minus 7 is 0, in which case x is 7. So we have our two answers for x here, minus 3 over 4 and 7. And then we have to decide, find the number of black counters in the bag. Well, again, x can't be negative. X represented how many black counters. We can't have negative 3/4 counters, therefore it must be 7. So we put in 7 for our 1 mark. Okay, so you can have a look through the big mark scheme here and get a good idea of exactly where you pick up those marks. Again, if you like this video, then please do like and subscribe. What I'm going to do is something slightly different to videos that I've done before. I'm going to leave one question for you. So I'm going to put this question here, question 12. So again, read through it carefully. I'm going to give you part B as well. So I've got question 12 here, part A, part B. Can you write down in the comments what the solutions to that is? And then later on, I'm going to put this PowerPoint into the description so you can check your answers. Okay, best of luck with that question. If you want more probability practice, my old school video from before on probability, then check that out right in front of you.